Okay, so here's where we left off. It says simplify, assume that variable exponents represent positive integers. The reason that that line is there is because, what just happened? Oh, there we go. If they weren't positive, some different things would happen, and we're not into that just yet. So we're going to talk about what would happen. Now, things are going to look weird and they're going to look different, but it's not going to change what we already did. So we're still going to approach it in the exact same way as before. So let's start breaking this down. Let's work on this one right here. What are the very first things that I'm going to do here? Same as when we had numbers. Okay, so let's attack just this part first. Let's do just this part. So I'm going to do that in red just to follow this. How do I do that? Okay, so that k is going to be distributed to this right there. And this becomes what? So what am I going to write? What's the exponent? 2k. It's just distributed there. That's all it is. Okay, so let's take a look at this portion then. So these two things are going to be multiplied together. So let me just go ahead and those things are going to be multiplied. What am I going to do with that? A to the k power and all of that being raised to the third power. What does that become? Okay, a to the 3k. All right, I just put the number out in front. That's all. It's just like when we've got 3x or 2x or 7x, I'm putting the number out front. Okay, well, we still have more work we can do. We can actually multiply these. When I multiply these together, what happens? What adds together? Okay, so we get a to the 2k plus 3k, which becomes a to the what? 5k. That's exactly the steps that need to happen on here. So we distribute, when it is in parentheses like that, when an exponent is being raised to another power, it gets distributed. So that's where the 2k came from right there. Here's where the 3k came from right there. And then since they both have the same base, we add their exponents. Yes, ma'am? So if they have the same base, you add their exponents. All right. So here's another situation, and it looks a little complicated. So if you are not rewriting as you're going, it's easy to get lost in something like this. What am I going to do first? What's my first step? I'm sorry, I just didn't hear you. Okay, but that's adding. We never really talked about adding two things with different exponents. So you're right that we should start in the parentheses if there's something I can do, but I can't do that because I haven't learned how to do that yet. Two things where it's like, I go, well, how do I do that? Because they don't have the same exponents. Okay, so let's distribute. Here's going to be my first distribution, and here's going to be my second distribution, just so you can see color coding it there so we can see where we're going. So the first distribution looks like this. X to the m minus n, times, I'm going to put this one in parentheses just to separate them so we can see m plus n. All right, so they have the same base. So what am I going to do with their exponents? Multiply their exponents? How? What do you mean? M times m? Did we multiply the exponents over here? We add their exponents. So let's just see. We've got m minus n plus m plus n. There's the first and the second one. So we're just adding those together. And let's see what happens. M plus m equals 2m. And negative n and plus n equals what? Here, negative n plus positive n. That becomes a 0, or just cancels out, leaving us just x to the 2m. So that first distribution in red is just x to the 2m. That's that first thing that got distributed. Now let's do the blue part. So here's going to be the first part of my answer right there, but let's work at the second part now as well. We've got x to the m minus n times x to the n. All right, so what should I write?
X to the
There's the two exponents being added together. I underline them to show where the two exponents are. All right, which becomes what? Right, the n's are going to cancel out again, leaving just x to the m. So it becomes x to the 2m plus x to the m. Now, if you have the feeling, like if your gut is telling you to turn this into x to the 3m, why would that be incorrect? Like I could see why somebody would go, oh, but that's just x to the 3m, and I would say that that's completely wrong. Why?
Because their exponents are the same.
They're not the same. So what are we doing with these two things? We're just leaving them just like that. We can only add them together if we have the same exponents, and we do not have the same exponents there. If they were both to the second power, to the third power, or both to the m power, if they had that same exponent, we could add them together, in which case that's all we can do is just leave it as x to the 2m power plus x to the m power. All right, let's try some of these down here. We'll do just the evens. We'll do 20, 22, 24, and 26 so that I've got time to give you your test back. All right, let's start with 20, and whoever wants to go first gets the power to throw people under the bus. Ozzy, you want it?
So first you distribute UV to everything. And then you get UV, I already know. It would be U to the second power to V, and then plus U V to the second power.
I'm just going to go over this in red because I had color-coded this red and then I switched colors. I just don't want it to be confusing. This is where the red part is right there. Okay, and then the blue part was U.
Plus V to the, U V to the second.
Okay? And what does that become?
U V to the second. And then it would be U V to the second plus V to the second power V.
So what if I was like, well, these are the same things, I can add them together. What would you tell me? Why am I wrong? Even though they've got the same numbers, u is to the second power in one of them, u is to the first power in the other one, v is to the first power in one of them, v is to the second power in the other. These do not have the same exponents, so that is exactly where we're going to leave it. Because those things would have to have the exact same exponents. Ozzy, who's going next?
You can figure this.
Oh, man. Would anyone like to volunteer to go next? Then you get the power to throw somebody under the bus. All right.
So you distribute the 4 y to the second power and times 8 to both.
Okay, give me a second to catch up there. We're doing that one right there.
And the first one would be, you,
I'm just actually going to write it so we can see what we're distributing. I'll let you actually do it. There you go.
it would be 4 y to the 4th power z.
Notice he added those two exponents together. 2 plus 2 equals 4. So there's our first one right there. I don't know why I keep switching from red. Sorry, I just want to make sure this is color-coded. Okay, there's our first term.
And then you multiply it by the negative z squared. Then you get negative 4 y to the second power plus, well, just z to the third power.
So we've got negative 4 y squared z to the third power. So now what is my final answer in all of this?
4y to the 4th power z minus 4y to the second power z to the third power.
Perfect. And we can't subtract those things or add those things. Why?
Because
The exponents aren't the same. Every single thing has to have the same exponent when it comes to variables. Variables have to have the exact same exponents. Each one of them must be exactly the same to add them or subtract them. Who are you throwing under the bus? Sorry, Abel. I wish I could say that this was a democracy, but unfortunately...
So which one am I doing?
24. So let's start here. We've got negative 2xy squared times x to the third power. Let me just switch that to red because I keep doing this. Negative 2xy squared times x to the third power. Talk to me. Let's do just that part.
You got a little further than I was thinking.
I got a little further? What were you thinking?
No, I was just
Because that was step
I
one.
was just looking at the question.
Oh, okay.
Yeah. So, negative 2x to the third power, and then the y to the second power.
So wait, it didn't change at all? The first thing didn't change at all? Oh wait, like we got an x to the oh no, I see, it did change. The x changed, but the y didn't. So, interesting. I don't know that I would agree with 100% of that, but I feel like it's pretty close. Where do I disagree with you? How about this? Let me give you this little hint. Does that change anything for you?
You're pointing at a y. I got that.
It's not an arrow. It's actually an exponent there. It's a 1.
Oh, all right.
Sorry.
Let's see. All right, so I see numbers and letters. You know, I'm getting that so far.
Okay, so let's go one by one. Here we go. Negative 2 times 1 is what?
How about I family feud this and get like a help?
How about you got it? Negative 2 times 1 is what?
What?
Negative 2 times 1 gives us what?
Negative 2 times 1?
Yep.
Yeah, negative 2.
Okay, so the negative 2 part you definitely got. Now the next part we're going to do the x's. X to the first power times x to the third power. When I multiply things with the same base, what do I do with their exponents?
You add them.
I do. So on this x, what exponent should be on there?
4.
A 4. So that looks like that was the only thing that might have been off there. And then we've got y squared. Okay, so let me just clear that up there. Like that was our first answer. That's the first part of the answer. Now we're going to do the second part of the distribution up there. You've got the first half of the answer. The second half happens here. Negative 2xy squared, that's this first part, times negative xy squared. Apply that same strategy right here.
So negative 2x to the third power.
Well, let's start with the numbers.
Oh, no, wait. No, never mind. I just realized. So, yeah, no, negative 2x. The x stays the same.
Give me 1 second. Talk about the numbers in front. Let's just talk about just the numbers. What? So here's a negative 2 over here. What number is in front of the other ones? On the right, that negative xy squared, this part right here, what number is out in front of those?
Negative 1.
Negative 1. What is negative 2 times negative 1?
Positive 2.
Positive 2. So our first number is a positive 2. All right? Now, I'm sorry, I interrupted you. Now we've got x times x. So x to the first power times x to the first power gives me
X to the second power.
x to the second power. There's my next part of it, x squared. And then finally,
And then 1 to the fourth power.
fantastic, y to the fourth power. Put it all together now. So we've got our two parts of our answers. We need to put it all together.
All right, so the 2's cancel each other out.
Interesting.
Right.
Do they?
I'm asking you. I'm not really sure.
So to be able to add two things or subtract them, if I want to add or subtract these things, what needs to be true about them? What, better yet,
All the factors got to be not factors, the exponents, they got to be the same.
right, does x have the same exponent as x?
No.
Does y have the same exponent as y? Okay, so what are we going to do with these numbers then?
Leave them as is.
We're going to leave them as is. Final answer.
You may clap now.
We'll get on that. We'll save that for the end.
Amazing performance.
All right.
I'm a certified genius.
All right. 26. Who's doing 26 for us, Abel?
Everybody I know will be good at it, sure. Run.
All right.
So it's gonna be
Let me just write this out down here just because it's high up there that I gotta, let me just rewrite this. N plus 1.
well the one negative one and the positive one will cancel out, right?
Okay, let me just take one step on here and let's actually just write this out that it's this. And then what are we doing with that n plus 1 and that n minus 1? They're adding them. Because sometimes it helps to just see it as that step. All right. So now, I'm sorry, go ahead with what you're saying.
So a 2n.
Because n plus n is 2n.
Yeah.
Yep.
And then the ones cancel out.
The one's negative 1 plus 1 just leaves us with a to the 2n. Okay, these are the same things that you're going to be doing on your homework tonight. So we did half of those on the notes there. So same thing you're going to be doing, but you need to know how to set these up. And I can tell you this, if you're not showing me that work of how you're getting there, if you went straight from here down to there, expect that I'm going to mark that question wrong. Even though you got the right answer. Why? Because I need to see how you got there. So that's what you're going to work on. Bless you. I'm going to pass your test back to you, and then we'll answer any questions that we've got on those.